Now we are moving on to the second experiment, just to familiarize and understanding the use of functioning of system calls used for operating system and network programming in Linux. Some system calls of Linux programming systems are PS, that means process status. If you type PS, what will happen? See here, PS, that means PS will show you what are the current process which are running on the system. We have only two processes. Bash means that is the Linux operating system, and PS means the program which you have or you have run, which is PS. That is the process status. PS minus L show you these are the details of these two processes. That means that details in detail you are not, that means PID means that is the process ID. That means for every process there is a process ID, and PPID means that is a parent process ID. That means the process ID of the current process is PID, and parent process ID is, that means any process is creating some other process, and the creating process is called parent process ID, and the child is the current process ID. Okay, now that is PS minus L. Now this is a very important process, which is fork. Fork means when you are forking, you are creating an exact replica of the current process. A process is having mainly a stack area, data area, code area, then everything is replicated. That means you are going to have an exact replica of the current process. Okay, then what is the difference between these two processes? That means once you have forking, that means this is an example of forking. That means this is a simple C program. Here int PID, this is int, you have a process ID, a variable PID which is of type int, and now you are going to have PID is equal to fork means, PID is equal to fork means here you are going to fork. That means once this is executed, what will happen? Now a process is a program in execution, and before processing or before running a program, you have to load that process into the memory of the computer, main memory of the computer, and it has got a code area, stack area, and data area. And once this fork is called, what will happen? It is having an exact replica of this process. That means it will load after creating a new process, that be loaded in different portion of the memory. That is loaded in the different portion of the memory. That means everything is exact replica, but one difference is the fork command. That means this is the parent process, and parent process is creating a child process. So PID is equal to fork means once you have created a new process, that will return the process ID of the child process you have created to the parent. So that PID value for the parent should be greater than 0, and that is the parent ID, that is the process ID of the child. Okay, now when you are forking, what will happen is create an exact replica of the current process. But one difference is you are creating, the parent is creating a child process, and in those two processes there are PIDs, that means exact replica, PID and PID. But PID of the parent is having the PID of the child. PID of parent is storing the process ID of the child, whereas for child this PID is 0. For the child this process ID will be 0. That means you have two processes which are exact replicas, but one difference is the fork returns to the parent the process ID of the child, whereas in the child the process ID value will be 0. So after this, that means up to this point, that means process ID equal to 4, you have only one process, and after that from this statement onwards you have two processes. That means you have two processes, and in one process you have PID equal to 0, and for the other you have PID greater than 0. So you are testing this. If PID greater than 0, printf I am parent, else I am child. I will show you how this can be executed. Okay, and that's all about a fork. And exec means new programs can be run using exec system call. New programs can be run using exec system call. When a process calls exec, that means execute some other process. The process is completely replaced by the new program. Suppose that if you are doing a program and in between you want to execute some other process, and after processing that if you want to return to the parent, for that what you have to do is you have to fork the current process. When you are forking the current process, what will happen? It will create an exact replica of the current process, and both of them are executing at the same time. And in the child process you have to execute a program, another program using exec system call. Then that child process will be totally replaced by the new program, and once the execution of that is completed, and it is sending that signal back to the parent process, and it can continue its execution. Okay, so I will show you all these things. And the wait system call is when a process terminates, its parent should receive some information regarding the process, like process ID, the termination status, amount of CPU time taken, etc. This is possible only if the parent process waits for the termination of the child process. And exit system call means when exit function is called, the process undergoes normal termination. The flowchart for this is like this. See, once you are forking, then definitely parent and child are created, and this child is for what is the purpose of creating a child? You want to execute some other program. Then after creating that child, the parent is waiting for the child to complete the execution of the program. Then after forking, using exec system call, the child does some other job, and after completion, it is when it is exiting, it is signaling the parent that it has completed the execution of its job, and once it is completed, then the parent can resume the execution of the program. Okay, that is all about fork. That means here for the fork system call, once you have forked it, it is creating two processes, and one process is the parent process and the other one is a child, and the difference between the parent process and the child process is its process ID return, and what the child does is executing some other program, and once the execution of that is completed, it has to exit, and once that exit command is executed, it is signaling the parent that it has completed, the child has completed its execution, and now the parent can resume the execution. Okay, now the next system call is open. This system call is used to open a file whose path name is given as the first parameter of the function. Open file path name. ORDWR means read and write. If you want to have read only, then O read only, RD only. If you want to open that for writing, then O WR only. So those are different types of opening. Here open file path name, as a first parameter we have to post the path name of the file you want to execute, and this is the opening mode. Either you can open it as read and write. Here this is reading and writing is possible, read only is possible, write only is possible. Okay, and next is a read. A read means this system call is used to read data from an open file. Once you have opened a file, then you can read that. That means read FD. This is the file descriptor. When you are opening this file, it will return a file handle, and this is the file descriptor, file handle or file descriptor, and the buffer in which you are going to store the read information, and this is the size of the buffer. Once this is executed, once this read FD buffer, size of buffer executed, this file descriptor FD is pointing to a file, and this buffer is storing the read information, and size of buffer means that much information you have to read. That means once this read instruction is executed, what will happen? Size of buffer, this much information is read from a file which is pointed to by FD, and that will be stored in buffer. Okay, the above function reads size of buffer bytes into and the array named buffer. Then what about write? Data is written to an open file using write function. That means write FD means file. This is pointing to a file, and this buffer is having the data to be written, and this is the size of the buffer. That means how much information you are going to write. So when this is executed, what will happen? The contents of this buffer is written onto a file pointed to by FD. Okay, so that's all about system calls as far as Linux is concerned, and those are the important ones are fork, exec, wait, exit, open, read and write. Important system calls related to network programming are: number one is socket. Socket is having three parameters: a domain, type and protocol. This system call creates a socket and returns a socket descriptor. If you are creating a connection to a file, then there is a file descriptor associated with that. Just like that, here if you are creating a socket descriptor is returned by that function, and if you want to point to that socket, you need only that socket file descriptor. The domain parameter specifies the specific communication domain. This selects the protocol family it will be used for communication. That means protocol family. These families are defined in syssockets.h. In this program, the AFINET family is used. As you know, there are two types of communication, which is connection oriented service and connectionless service. Connection oriented service, you are using SOAK stream, and that is TCP connection and UDP connection. If you are using TCP connection, SOAK stream is used, and if you are using UDP connection, SOAK dgram is used. The protocol specifies the protocol used is always 0. The header files used are systypes.h and syssockets.h. That means if you want to create a socket, you need the domain, you need the type, that means whether it is UDP or TCP, and the protocol, which is the protocol family used. That is for creating a socket. Once a socket is created, you have to bind an IP address to that. That is using bind. The system called bind associates an address to a socket descriptor created by socket. That is int bind socket. This is once you have created a socket, you have a socket file descriptor. Then struct socket address star my address means that is the address, and int address len means length of the address. Second parameter my address specifies the pointer to a predefined address of the socket. its structure is a general address structure, so that the bind system call can be used by both Unix domain and inter-domain sockets. Okay. Other system calls used are listen, announces willingness to accept connection, that means give queue size. That means once you have a, suppose that you have a server, whether it is a file server, whether it is a domain server, whether it is a web server, or whatever file server, or whatever it is, if you have a server, it is always listening to a request from the clients. So for that you can make use of this listen. Accept means, suppose that you are listening to outside request. Once you have received a request from some client, you can accept that using accept system call. And connect means actively attempt to establish a connection. When it means if you want to connect to a separate address, IP address, you can make use of this connect. Send means send some data over the connection. Receive means you are receiving the data, and close which releases the connection. So these are the important system calls associated with Linux. Thank you.